Gas keeps us warm in winter, allows us to travel, and feeds the stove we use to cook. In Western countries, gas is an essential resource for many aspects of life as we know it. But how much do we really know about how it gets to our homes? Welcome to The Journey of Gas, a podcast by Flavia Bazzano and Marianna Betti about the human element of energy production and distribution. Welcome to the first episode of The Journey of Gas. I am your host, Flavia Bazzano, and with me there is Marianna Betti, a postdoc in social anthropology from the University of Bergen, specializing in political ecology. Thanks to her experience studying on board gas carriers, together we will try to tell, in the form of a journey, the technical and human characteristics of the natural gas supply chain. The starting point of our journey is the land, the source of our natural resources. Let's give some technical information right away. Where are the major deposits in the world?
Yes, Flavia, there are several countries in the world with major natural gas deposits. And it is very important to know where the gas we consume comes from because it helps us to better understand the world market and also the geopolitical situation we experience every day. Among the top places is Russia. Russia is the world's largest producer of natural gas, accounting for about 20% of the world's production. Natural gas in Russia is mainly found in fields in West Siberia, in northern Russia, and in the Russian east. It's interesting to know that the gas supply to Europe via pipelines from Russia has been halved since Russia invaded Ukraine. As I will explain later and in other episodes, these sanctions and disruptions have been the major forces behind the recent expansion of LNG transport by sea. Iran is the second largest country in the world in terms of natural gas reserves, and Iran has about 18% of the world's reserves. Iran's natural gas fields are mainly located in the Persian Gulf region and also in South Pars field, which is shared with Qatar. In fact, Qatar is the third largest producer of natural gas in the world, accounting for about 12% of world production. Natural gas in Qatar is mainly found in the North Field, which is one of the largest natural gas fields in the world. Right now, a great deal of LNG used in Europe comes actually from Qatar. And then we have the United States, which is the fourth largest producer of natural gas in the world, with about 7% of the world's production. Natural gas in the United States is mainly found in the shale gas fields of Appalachia and in Texas. The US is probably the leading supplier of gas to Europe since Russia was cut off from the market. And finally, there is Canada, which is the world's fifth largest producer of natural gas, accounting for about 5% of world production. Natural gas in Canada is mainly found in Alberta region. Other major natural gas producers include China, Australia, Norway, Algeria, and Indonesia. Norway in particular is interesting because Norway is the largest gas producer in Europe. In Norway, gas is mainly found in the Arctic zone outside the city of Hammerfest. Most of Norway's natural gas is extracted from offshore fields which are located in the northwest coast of Norway, as for example the largest field which is called Snøhvit. And I'll talk more about the role of Norwegian gas at the end of our podcast.
First stage, land. Once a site is identified, how is gas extracted? What are the steps that lead from natural gas to liquefied natural gas ready for transportation?
This is a long and complex story, and each gas has a different origin, but I'll try to give you a little summary here. Once a natural gas is identified, as you said, after the usual geological investigations, a series of activities are performed to extract the natural gas from the reservoir. The first one is well drilling. So a well is drilled that penetrates the natural gas field. This well can be vertical or horizontal, or both, because things are never that simple underground. and the well can reach a depth of several kilometers. Once the well is drilled, natural gas is extracted from the reservoir using pumps and other tools such as directional drills, diamond crowns, and jackhammers. The gas extracted is never clean. Extracted natural gas contains, in fact, impurities like water, soil, carbon dioxide, and hydrogen sulfide. These impurities must be removed from the gas to make it usable. The natural gas is therefore sent through a pipeline to a natural gas processing plant where the impurities are removed and the natural gas is compressed. Once purified, the gas is converted to liquefied natural gas, which is the short is LNG. And it is compressed by cooling the gas to a temperature of minus 162 degrees Celsius. Gas cooling machines are called liquefaction units. They're also called train, and they are exceptional machines that use a compression cycle of refrigeration. After being liquefied, the LNG is stored in tanks, or it is immediately transported on tankers, which also are called gas carriers. Once the LNG reaches its destination, it is converted back to natural gas for use. At this point, it is distributed through a network of pipelines and it is used for domestic, industrial, and commercial purposes, such as for heating, for generating power, and as fuel for vehicles.
Perfect. So now we know what happens to the gas. And my following question is, what happens to the land after the extraction? Is it possible to predict the expected lifespan of a reservoir?
Oh, Flavia, another long and complex and very often controversial story, but I'll try to give you a small summary here again. Once natural gas is extracted, the ground is, of course, disrupted and it changes. The extension of the change obviously varies depending on the extraction method which has been used. For example, if gas is extracted by hydraulic fracturing or fracking, there can be dramatic environmental effects. This can be pollution of underground aquifers or risk of induced seismicity or loss of biodiversity. And these negative changes destroy the ecosystem in the long term. In theory, gas extraction can be done using more traditional drilling methods, in which case environmental impacts can be minimized. And we should point out that, in general, natural gas extraction companies, they must comply with environmental regulations and they must adopt sustainable practices to minimize environmental impacts and preserve natural resources. As for the question on the life expectancy of a gas field, this of course depends on several factors. And these factors are, for example, the size of the field, the production rate, the technology used for extraction, the cost of extraction, and last but not least, the price of gas in the market. In addition, natural gas fields are no renewable resources, we have to remember that. And once they are depleted, they cannot be replaced. And so, gas extraction companies must plan ahead and they must ensure sustainable resource management and maximize natural gas production, while, of course, maintaining safety and environmental sustainability.
With this topic, we deal more closely with the human component of our first stage. In fact, the practice of fracking keeps raising quite a discussion globally. Last year, in 2022, The Guardian published an interesting article about it based on a study from the Energy Policy Journal. The authors of this study defined the effects of the fossil fuel extraction plan initiated in the central United States, and I quote, a real carbon bomb that would lead to disastrous consequences for the climate, just as you told us. Are the prospects really that alarming?
Flavia, I cannot lie to you that yes, the scenario suggested by the study published by the Energy Policy Journal is truly alarming. Natural gas extraction by fracking has increased fossil fuel production in the United States, but it has also led to disastrous consequences for the climate and the environment. Unfortunately, fracking techniques involve the use of large amounts of water and toxic chemicals, which can contaminate groundwater and the surrounding environment. And also, fracking releases large amounts of methane into the atmosphere, a greenhouse gas that is much stronger than carbon dioxide in absorbing heat. This has contributed to the increase in greenhouse gas emissions in the United States and around the world, contributing to climate change dramatically. You might have heard about this year's news of that methane leakage from oil fields in Turkmenistan that was so massive to equal Britain's total carbon dioxide emission. This was a real disaster that pulls us back years in the fight against climate change. As you mentioned, Flavia, the study published by the Energy Policy Journal suggests that fossil fuel extraction in the central United States, and in particularly the extractions of shale gas in the Permian Shale Basin, represents a real carbon bomb. This carbon bomb could lead to a significant increase in greenhouse gas emissions and could lead to a consequent severe impact on the global climate. In addition, the study questions the economic viability of this type of extraction. In fact, the costs of extracting shale gas might definitely exceed the profits made from its use. As I explained earlier, not only to extract but also to cool down and to store gas is very expensive and technologically advanced, not too viable like we say in economics. However, right now the gas has a very high value in the market, and so we can continue with extraction, processing, and transportation. But it might very well end up being a ticking time bomb, as predicted by the study.
So it appears clear that fracking can impact also the health and quality of life of the communities living next the extraction sites. What do we know about this?
Fracking is a bugbear in the industry of resource extraction. One of the main health risks associated with fracking is the exposure to toxic chemicals that, as I explained earlier, are used during the extraction process. These chemicals can contaminate groundwater and the surrounding air, and the people living near extraction sites can be exposed to these contaminants through drinking water or breathing air and consuming the food. This exposure may be associated with an increased risk of respiratory diseases, to skin problems, endocrine disorders, and neurological diseases and cancer. Fracking can also have negative impacts on the quality of life of the surrounding communities. And for example, heavy traffic, noise, light, dust can increase around the extraction sites. And this can disrupt people's daily lives and interfere with the quality of their sleep, for example. Worldwide, there are several examples of communities that have suffered negative impacts in the forms of worsened health and well-being from fracking. In Pennsylvania, communities have been reporting health problems for years, and these being respiratory illnesses, gastrointestinal disorders, headaches, nausea, dizziness, and problems in gestation and childbirth. In the province of Alberta in Canada, there have been reports of increased risk of cancer, particularly leukemia, in the communities living near tar sand mining sites. In Queensland, Australia also, there have been reports of contamination of drinking water reservoir near gas sites, which have obviously affected the health of people living there.
Probably these are some of the reasons why fracking is not used on a large scale in Europe, and this is why we import natural gas from abroad. I wonder then, in the case of minorities or communities that are affected by the consequences of extraction, to what extent can we talk about environmental racism?
Bravo, Flavia, very good. You are touching on another very sensitive and important topic here. The negative consequences of fracking are so many and so difficult to contain, even in the best intentions, that so many countries in the European Union have decided to stop and even ban fracking. Let alone now the European Commission in its long-term strategy of making all of Europe climate neutral by 2050. In fact, even though the EU has not banned fracking completely, and each EU member state has the power to decide whether or not to allow it within its national borders. However, the member states are very reluctant to do fracking, and even if they would get strong resistance from local communities anyway. In addition, the EU is incentivizing the development and use of renewable energy sources such as solar and wind power to reduce dependency on natural gas and on other fossil fuels. To sum up, the EU's long-term strategy envisions a transition to a more sustainable energy system, and in this vision, fracking could play a limited role and even be excluded. And also, this vision is increasingly supported by major economic actors, and it is promoted and publicized by politicians. But let's continue with your question. Environmental racism is a very important concept. It is when ethnic or socio-economic minorities are exposed to greater environmental risk than the general population, and especially than the hegemonic elite groups. In the context of gas extraction through fracking, there is evidence to suggest that ethnic minorities and low income communities are at greater risk of suffering from air and water pollution, and they are more vulnerable to other negative impacts on their health and their life quality. Like the local Indian communities in Alberta and in Pennsylvania that I mentioned earlier, but there are also the Aboriginal communities in Australia, as well as ethnic minorities in the Permian region of Russia, where the world's largest gas fields are located. In general, low income and ethnic minority communities are often less able to assert their rights, and also they are less able to obtain information about mining activities occurring near their homes. The knowledge is power, and these initial gaps create significant long term consequences. In addition, these communities may be more vulnerable to the impacts of fracking due to factors such as substandard housing or lack of health insurance and limited access to health services. Most often, these communities live in remote, neglected locations where national interest is minimal and infrastructures and industrial development almost do not exist. Mining projects can be deceptive to local communities. And in fact, the local community might expect jobs and prosperity from them. And at times, they might expect these jobs and prosperity to come to them overnight. And very often, the reality is different. Moreover, the impacts of fracking do not stop with local communities. Globally, extracting and burning increasing amounts of fossil fuels contributes to climate change. And climate change has particularly negative impacts on the most vulnerable communities, least able to adapt to it. Bangladesh, Pakistan, Libya, to name three desperate cases we have heard so much about in the recent months. These countries have been devastated by flooding and torrential rains.
We've come to the end of our episode. Our journey will continue with a new episode dedicated to the anthropological significance of gas extraction. Marianna, would you like to give us a hint?
Yes, my field, social anthropology. Anthropologists have a privileged and essential role in knowing and understanding more deeply individuals and social groups in very different places and contexts. The anthropologist can gain very detailed and qualitative descriptions about the people she studies and the social processes that construct the dimensions in which these individuals operate. This is done through field research and the qualitative methodology I mentioned at the beginning of the episode. The anthropology also should have the skills and tools to analyze the social, cultural, and economic processes which condition human beings. And for example, in our case, the extraction, distribution, and consumption of natural gas is viewed from a human and social perspective, not from a more commonly used economic or political perspective. Questions we anthropologists ask, for instance, in a context of gas extraction are: how do these projects affect local traditional subsistence practices? How do they affect people's identity? What are the social and economic dynamics that might arise around extraction sites, refineries, and transportation infrastructures? We anthropologists address issues such as employment and labor, wealth distribution, impacts on health and the environment. We ask what role do values, family systems, traditional hierarchy play? What importance is given to the indigenous knowledge of nature and resources in the context of resource extraction? And if no space is given to this knowledge, what does it mean in terms of power relations? And finally, what impact the inability and resistance of industries to other knowledge might have in the outcome of mining and processing operations? In addition, anthropologists can analyze the role of international institutions and organizations involved in industry of natural gas and also their policies in order to better understand the global dynamics which affect natural gas production and consumption. And basically, anthropology can provide a deeper understanding of the social, cultural, and economic processes involved in the industry of natural gas and can help understanding also the impact on the communities involved so that more informed and just policies can be developed for the management of this important resource like natural gas. And especially regarding this topic, the anthropologist's perspective, you will agree with me, Flavia, is very important.
Thank you for listening to The Journey of Gas, a podcast written by Flavia Bazzano and Marianna Betti. This podcast is produced by Flavia Bazzano. The music is composed by Lexin Music.